Hello everybody, BlackEyedGhost here, and today I'm going to be starting a series of videos on linear algebra. In order to better understand this first video, it'll help to know what a real number is, what a variable is, how to plot coordinates on a graph, and what the Pythagorean theorem is. In this first video, I'm going to be talking about vectors. A vector, simply put, is a list of numbers. When writing vectors, you write your numbers in a column, and you put square brackets around them. Vectors can also be represented with variables, just like normal numbers can. But when you write a variable for a vector, you'll draw this little arrow above it. Sometimes you'll also see bold lowercase letters used. When defining vectors, we use this notation. This can be read as v is a member of R to the n, or v is a member of Rn. What this means is that v is a list of real numbers and it has n elements in it. Whatever's on the right in this notation is called your vector space. In order to understand vectors more intuitively, we often represent them using arrows. The bottom of the arrow is called the base. The other end is called the tip. When representing vectors this way, we usually draw them in what's called standard position, which means the base of the arrow is at the origin, where all of the axes come together. A nice thing about representing vectors this way, though, is that you don't have to draw it in standard position. Sometimes, like when you're adding or subtracting vectors, it's more useful to draw them in non-standard position, such as at the end of another vector. R2 vectors are the easiest vectors to represent this way, because you're drawing on a two-dimensional grid. All vectors have direction and magnitude. Direction is which way the arrow points. Magnitude is the length of the arrow. Whenever you draw a vector, you need to make sure that the direction and the magnitude is correct. So long as you draw the arrow pointing in the right direction and the length of the arrow is correct, it doesn't matter where you draw it, because it will still represent the same vector. The magnitude of a vector is denoted by vertical lines on either side of the variable. Sometimes you'll see it written as one line, sometimes you'll see it written as two. We can calculate the magnitude of a vector using the Pythagorean theorem. In doing so, we get this equation. Given any vector v, you take each component, square it, add them all up, and then take the square root. There's a special vector that I would like to touch on, and that's the zero vector. The zero vector is a vector with a value of 0 for every single item in the list. Just like variables, the zero vector can be represented as a 0 with an arrow above it, or with a bold 0. The zero vector can be thought of similarly to the origin, since the origin is the point 0, 0 on a 2D graph. In the arrow representation of vectors, the zero vector doesn't work very well, since the arrow would have a length of 0. Because of that, I'll be representing the zero vector with a red dot. The magnitude of the zero vector is 0. But since it doesn't point in any particular direction, it's easiest to think of the direction as 0, since it's not positive or negative in any direction. Let's go ahead and do an example to bring together what we've learned. To start out, we're given the vectors 1, 2, and -3, 1. Let's start by assigning a variable to each of them. 1, 2 will be x, and -3, 1 will be v. We know that both x and v have two elements in them, so that means they are both members of the vector space R2. Next, let's go ahead and draw x in standard position. Drawing in standard position means we start at the origin, and then for x, we move right 1, up 2, and then draw the arrow between the 2 points. Since we drew our x vector in standard position, let's go ahead and draw our v vector in a non-standard position. So, let's go ahead and start from the tip of x, move left 3, up 1, and draw our v vector. Next, let's find the magnitude of x and v. To find the magnitude, we take each component, square it, add them up, and take the square root. For our x vector, 1 squared is 1, 2 squared is 4, 4 plus 1 is 5, and so the magnitude of x is the square root of 5. For our v vector, -3 squared is 9, 1 squared is 1, 9 plus 1 is 10, so the magnitude of v equals the square root of 10. Well, that's it for this video. I'll catch you guys next time.